Hello and welcome back. We're going to be kind of continuing on from the last set of problems that we just encountered with identifying whether or not a molecule is polar or nonpolar. When dealing with these types of problems, the first thing that you always want to do is write out the Lewis structures. Once you write out the Lewis structures, you can then identify if you have any polar bonds, because once you identify if you have a polar bond, you can then work on to identifying the molecular geometry. For the first case, hydrogen-bromine, we're going to look at this molecule and we're going to start to identify whether or not this molecule is polar. Off the bat, we know that bromine is significantly more electronegative than that of hydrogen, and so we're going to have a polar bond, or this is going to be a polar bond. In this case, we don't have any other bonds to take in consideration, so this is going to be a polar molecule. In the case of methane, so CH4, we draw the Lewis structure, and then we look at it to determine if we have a polar bond. In this case, we know carbon-hydrogen bonds are not polar, so that's all we have. So this is a non-polar molecule. Lastly, we have carbon disulfide, so CS2. We drew out the Lewis structure. Carbon-sulfur is a polar bond. Then we start talking about, start going into the fact of what's the molecular geometry. Well, since it is a linear geometry, and both of these sulfurs are the same, they're going to have the same electronegativity, so they're going to be pulling in the same direction, thus having a net dipole of 0, making this a non-polar molecule. So it's very important when you start breaking this down, you take in consideration the bond angle, the electronegativities, and whether or not it's going to be a polar or nonpolar molecule based on those factors. Thank you.